Thank you so much for joining this lesson. We're going to discuss the Mokasa 1 2025 examination. It's good for you to remember that our consultation line is already on the board here, 0704 153366. It's also good for me to make aware that the paper that we are just about to revise, the section 1, has already been uploaded in the same platform. That is a Shifting Grades online school, which is on YouTube. So please find time and follow up with the section 1 because we have already discussed everything. Now, in the section 2, we are going to revise the questions one by one until everything is learned very well. Thank you so much for tuning in. You can share this link to invite more friends. Remember to comment, remember to like, remember to subscribe. Just be a full member in Shifting Grades online school. Before we proceed, allow me make you aware of a few programs that we have around for you. Yes, some of the programs that we have are the individualized online classes here, which are happening on Zoom, on Google, sorry. So Google Meet, we are doing some lessons here. You can purpose to join us. Register through my number, which is still displayed here, 0704 33 66. So just get to my WhatsApp or make a call for more information. We'll be discussing the STEM subjects. That is mathematics, physics, chemistry, and biology. And we hope that you people shall benefit from this program. Remember also to acquire airtime through our platform here, whereby you just need to go to the M-Pesa, Lipa na M-Pesa option. Then the pay bill is displayed here. Our pay bill is 73.56. Then the account number is the phone number that you're purchasing the airtime for. This can even be the phone number of a friend or even yours, Safaricom, Airtel, Telcom. Then now the amount is whatever amount that you'd like to spend as airtime. You complete the transaction and you receive the airtime instantly. Now, back to the paper now, number 17, part A. A solid cube is made up of a hemispherical bottom, a cylindrical middle, and a conical top. The height of the cylinder is 14 meters, and the height of the cone is 5 meters, and the common radius of both figures is 2.1 meters. Take pi as 22 out of 7. Part A, find the slant height of the cone correct to 2 decimal places. The first thing that I'm going to do here is to apply a skill which is called sketching of diagrams. Diagram sketching is one of the skills which make most of the questions in mathematics simple than they appear. So if we put this information in a simple diagram, we will be able to interpret it easier than operating it the way it is. So there is a solid here, which is made of hemispherical bottom, a cylindrical middle, and a conical top. So there is a middle here, which is made of a cylinder, cylindrical middle. We know what a cylinder is. So this is a cylindrical shape, which is making the middle part. I'm going to draw it that way. Then after this now, we are told that the bottom is hemispherical. So when we say hemispherical, we mean half of a sphere. This is the bottom. And now there is an hemisphere there. That is half of a sphere. Then on the top, we are told that it's a cone. So there is a conical top. So on top, we have a cone resting here. You got a cone resting here. Yeah, a cone resting there. So this is generally how the solid is. We are having a height of 14 for the 14 meters. That is for the cylinder. Then we have a height of 5 for the cone. So for the conical part, the height here is 5. So for this cone, we can say that this height is 5 meters. Then something else provided is the common radius for both figures. That means we have 2.1 meters, and also the radius on the lower side is 2.1 meters. The first thing that we are solving here is the slant height of the cone. So for the cone, we shall apply what we call the Pythagoras theorem, because through the center to the middle or to the base of the cone, we are having a height of 5. Then the radius is 2.1, which means using 2.1 and 5 meters, we can get the slanting height of this conical part. So we need to say that the slanting height, which is L squared, equals to, it is now going to act as the hypotenuse for this particular case. So it shall be given us when we take 5 squared plus 2.1 also squared. Then now to remain with L, we need to obtain the square root of everything here, which is 29.41. That way. And with this, you get the slanting height is 5.42 meters. Remember the instructions of 2 decimal places. You must be very careful with instructions. Look at part B. Find the total surface area of the solid Q. Correct to 4 significant figures. Total surface area. So we need to get surface area, and for us to find surface area, we just need to add all the faces that we can see making up this figure. 1 is a cone, 2 is a cylinder, 3 is an hemisphere. So for the cone, which is on the top, surface area, or the curved surface area, is usually given by pi r L. In this case, r is the radius, L is the slanting height. Therefore, we are talking about 22 out of 7. That is the pi, a radius of 2.1, and a slanting edge 5.42. This is going to give us 35.77 meters squared. Then we have the cylindrical part. So for a cylinder, we usually use a surface area of 2 pi r multiplied by height. 2 pi r h. So we need 2 pi r times the height of 14. According to the instructions there, we are having a height of 14 for the cylindrical part, 184.8. Square meters. Then we can have now the the bottom, which is an hemisphere. Yeah, so the hemispherical bottom. The hemisphere will be given by, remember, surface area of a sphere is usually given by 4 pi r squared. Now that we are talking about half a sphere, we will need to multiply this one by half, and this will become 2 pi r squared. 2 pi r squared. So 2 pi r squared. So this shall give us 27.72. Then now we can get the total, whereby you should add We should add all the values now, 35.77, 184.8, 27.72. This will give us 248.3. 248.3 square centimeters. Then there is the part B now, the part C, sorry, which is the last for this particular question. Find the volume of solid Q to the nearest meters. To the nearest meters, which means we are going to round off to the nearest whole number. To the nearest whole number, that way. So volume, again, we consider the shapes which are making up the solid there. The first one is a cone. The first one is a cone. So cone being a pyramid, we will talk about volume being given by a third base area times height. So a third base area being circular by r squared, then times the height. So a third pi r squared times the height of the vertical height of exactly 5. So this is going to give us 23.10 cubic meters. We have the cylinder. We have the cylinder, which is given by the volume of a cylinder is usually given by pi r squared times h. Pi r squared multiplied by height. So pi r squared times the height of 14 for the cylindrical part. This will give us 194.04. 194.04 cubic meters. And finally, we have the hemispherical part. So for the hemisphere, we will have, remember, for a complete sphere, it is usually 4/3 pi r cubed. This is the volume of a complete sphere. Now that we are talking about an hemisphere, we should multiply by half. And this results to 2/3 pi r cubed. So we will apply 2/3 pi r cubed. So 2/3 pi r raised to power 3. This is going to give us 19.40 meters cubed. So to get the total volume, we just need to add everything. So when we add, we get 236.5 meters cubed, but there are further instructions of nearest cubic meter, right? Yeah, nearest meters. Actually, this should be nearest cubic meter because it's volume. Nearest cubic meter. So we need to the nearest whole number, which is 237 meters cubed. So this is where the final mark will be awarded. Thank you so much for following up with that part. I would encourage you to continue sharing our link so that more friends might join our program. Remember to comment. Let's know where you are following us from. Let's know where you school. Yeah, let's know how the lessons are. So that is a number 17, which is the first question in the section 2. Now, talking about the second question, which is in number 18, it's on equations of straight lines and gradients. The equation of a straight line, L1, is given by 6x plus 3y minus 12 is equivalent to 0. Another line, L2, is perpendicular to L1 at a point M3. At a point M3, all right? Then line L2 also passes through a point K, which is 3, 5. Find the value of M, that is our Roman 1 in part A. So let's now interpret these instructions until we find the value of M. So in the first case, what you're supposed to know is that when two lines are perpendicular to one another, their gradient, that is the first gradient, multiplied by the second gradient, should always give us -1. Something else that we're supposed to know, we can extract gradient of an equation, gradient of a line from the equation if the equation is in the format y equals to mx plus c. Now that equation of L1 is provided, we can rearrange it to the format above, such that we write it as 3y equals to, now we take 6x to the right, whereby it will be -6x. Then we also take 12 there, whereby it shall be positive because this is -12. So -12 becomes positive to the right-hand side, but +6 becomes negative to the right-hand side. So for us to remain with y, now we have to divide through by digit 3, whereby this will become -2x plus 4. Now, when the equation is in this format, the value of M, which is just the coefficient of X, is usually the gradient. It's also good for you to know that the constant Y is the y-intercept. But from our equation here, we are interested on the gradient. So gradient of L1, which I may call gradient 1, is equivalent to -2, which means we can get gradient 2, which is the gradient of another line L2. The gradient for L2 now is half. So that when half is multiplied by -2, we result to a -1. You see that? It's also good for you to know that extracting or obtaining the second gradient is usually very simple. When you get used to this concept, you realize that you don't need to multiply anything or work out anything for you to get the second gradient. You're just supposed to know that the other gradient, which is for a line perpendicular to the one that whose gradient you're already having, is the reciprocal with the opposite sign. If, for example, we are having -2, we just need the reciprocal of this, which becomes a half, but now with a positive. Yes, so that the -1 is introduced in the product. Now, with this gradient, and we have two coordinates where this line passes, we have the first point and point K. So we can say that a gradient, which is usually given by change in y over change in x. So we'll say half is given by change in y, 5 minus 13, out of change in x, 3 minus m. That way, 3 minus m. So we can talk about half equals to, now when we take 5 and we subtract 13, we are getting a -8. Then this is divided by 3 minus m. A cross multiplication here will give us 3 minus m, that one has been multiplied by 1, equals to 2 by -8, whereby we have 3 minus m equals to -16. And hence, the value of m, we are now dealing with a linear equation whereby we are supposed to find a known. Very simple. We can take m to the right where it becomes positive. Then we take -16 to the left where it becomes positive. So 3 plus 16, which is a 19. So the value of m is 19. That way, the value of m is 19. It's my hope that you guys have followed very keenly. That way. All right. We have a part 2 of the same question. Find the equation of L2 in the form ax plus by plus c equals to 0, a, b, and c being integers. So we need to say that we just need to express gradient. Gradient equals to change in y, we use gradient, one of the provided coordinates, like the first coordinate, which is 19, 13. We have another coordinate, which is 3, 5. And we also have another coordinate, which is xy. So we shall use xy together with any of the two coordinates. Allow me use xy together with the first coordinate. So it will be y minus 5, that is expressing my change in y, divided by change in x, which is x minus 3. So across multiplication here will give us x minus 3 equals to 2 into y minus 5. So at this point, we can have x minus 3 being equivalent to 2y minus 10. Now, to remain with a 0 on one side, we need to talk about x. So the term with x should begin, then followed by the term with y, whereby we have to bring now 2 here, and it becomes, 2y becomes negative on the left-hand side. Then we are having negative 3, and we are supposed to add 10, because 10 is negative on the right, should become positive to the left. So negative 3, when we add 10, we're supposed to get a positive 7. Then now a 0 is retained on the right-hand side. Similarly, when you are expressing the equation, you are not limited. You're not limited to any of the, you're not limited to any of the coordinates out of the ones provided. So this can still be solved by saying that the gradient of half is given by change in y. Y minus the y coordinate in the first, which is 13. This one should be divided by change in x, x minus 19. Now, across multiplication will give us x minus 19 equivalent to 2 multiplying everything there, which will be 2y minus 26 that way. Then now the arrangement of this equation, so that you may stick to the format dictated up there. Start with x, then 2 coming to the left will become negative 2y. Then now we have a negative 19, but when negative 26 comes to the left, it shall be added, so plus 26. This gives us a positive 7. And this is equal to 0 that way. So we can use any of the provided coordinates. That is it. But you don't have to do it twice. Just choose a coordinate for you to express the equation. Here, part B of this. The equation of the base AB of an isosceles triangle ABC is y equals to negative 2. The equation of this side BC is y plus 2x equals to 6. Again, if the points A and C are negative 6, negative 2, and negative 1, 6, find part 1, the coordinates of B, and part 2, the equation of the side AC. Allow me begin by just sketching all this information, just sketching the triangle ABC. And I will sketch it with a lot of analysis. I will not just do it anyhow. What would be very keen. The triangle first is isosceles, meaning that there are two sides which are equal. So the first thing that we're supposed to know is that line AB, which I guess is now this one, line AB should be an horizontal line. This line is line, this one, this line, this one is line Y equals to negative 2. Then something else that we supposed to know is that the side BC which now automatically has to be this one. Let me rewrite the equation. Y equals to negative 2x plus 6. You see, the equation is having a negative gradient of 2. That is why it is sloping this way. So we have y equals to negative 2x plus 6. That way. Something else that we're supposed to know is that the coordinates of A are given as negative 6, negative 2. Then the coordinates of C are also provided as a negative 1 and positive 6. That way. Find the coordinates of B. Find the coordinates of B. So one thing that we're supposed to know is that B is the intersection of AB and BC. Therefore, where these two lines are meeting, that is the point of intersection. So at B, something that we are sure is, because the line AB is y equals to negative 2. It is only the x value that we don't know, but the x value is a negative 2. That is something that you ought to understand. So now, for these two particular lines which are meeting here, when y is negative 2, what will be the value of x? So we say the equation y is negative 2. So negative 2 from this equation now, negative 2 equals to negative 2x plus 6. And you know this one can be brought now to the right, not to the left. Okay, so that negative 8 equals to negative 2x. When you divide through by negative 2, the negatives cancel. The value of x become 4. If the value of x is 4, when y is negative 2, then the coordinates of B can now be stated as 4, negative 2. That way. The other thing is find the equation. Find the equation of a side AC. Find the equation of side AC. Now for AC, you know, we are already having both coordinates provided. So we need to follow now the form 2 concept whereby we need to get gradient. Gradient will be given by change in y. So we need to take 6 minus a negative 2 divide by the change in x minus 1 minus a negative 6. Negative 1 minus negative 6. That way. So this shall be 8, if I'm right, yeah. Then on the lower side, we have a 5. So 8 over 5 is the gradient. So we express now this gradient. 8 over 5 equals to, we have to use the two provided coordinates and another coordinate, xy. So we use either A or C together with xy. Allow me use A. So y minus negative 2 divided by change in x, x minus a negative 6. So from this point now, we can say 8 over 5 equals to y plus 2 out of x plus 6. A cross multiplication here will give us 5y plus 10, because I'm multiplying 5 with everything there, then equals to a cross multiplication again on this side, whereby I shall be having 8x plus 48. That way. Remember, we've not been given the format into which we're supposed to write this equation. So we can give it any format. So actually, after grouping the constants now, we can just have it as, we can have it as 8x minus 5y, 8x minus 5y plus 38 being equal to 0. That is one format. We can use several formats. At the end of the day, the objective is getting the the equation. At this point, we can also say that 5y equals to 8x minus or positive 38. And we can remain with y by saying 8 over 5x plus 38 over 5, such a thing. Okay, so we just need, our intention is to get the x, the equation. And for this particular case, the format has not been specified. Let's get to the third question, which is number 19. A curve is represented by the function y equals to a third x power 3 plus x squared minus 3x plus 2. Find the gradient function of the curve. Now, what we call gradient function is usually the derivative of a function. So we have to derive, we have to differentiate, in other words, the differentiated value of this. So the differentiated value, we call it dy dx, which will be given by, we drop the power here, so that now we are having a third times 3. And that way, the 3 will cancel. Then we will get x raised to, the power reduces by 1. So it was cubed. Now it becomes power 2. In the next term, we shall drop the power here, which is power 2. So we drop it here. It will be 2x. And because x was to power 2, now it becomes power 1. Then minus 3. Remember here we are having x power 1. So we're just dropping 1 here. Negative 3 times 1 remains negative 3. And x, which was to power 1, now becomes power 0. So we are having negative 3, x power 0. Remember, anything power 0 is 1. That is why now the x will have to disappear, because it is negative 3 times x power 0, which turns to 1 that way. Now, the constant here has to disappear during the differentiation, sorry. When differentiating, we usually have the constant disappearing. Reason being, for us to have 2, it means there is x, which is to power 0. Now we have to talk of the 0 being dropped here. So that 2 times 0 becomes 0, and that will make everything else a 0 at that particular point. So in this case, I would say that we are done with the differentiation, and that is the value of the gradient function. Look at part B. Determine the turning points of the curve. Something that you're supposed to know is that the curve turns when gradient is 0. So at the turning point, which are also called the stationary points, that is another name which can be used interchangeably with turning points. So turning points are also called stationary points, and at the stationary points, gradient is usually 0. So now that we have gradient function, then we just have to equate it to 0 so that we know the values of x at those particular points. So the gradient function can say that at the turning point, the gradient equals to 0. This is a quadratic equation, and it can be solved using one of the several methods of doing the same. So solving a quadratic equation can be done using the quadratic formula, the completing square method, the factorization method. So that we may accommodate the Form 2s who are following this, we need to prefer what we call the factorization method. For the Form 3s and Form 4s, kindly review completing the square method and the quadratic formula, which is still uploaded in the same platform. All right, so we need to look for, the equation is in the format ax squared plus bx plus a constant equals to 0. This is the general format. So we need a product of a times c, which means 1 times a negative 3. Then a sum of the value at b, which is at 2. We need 2 factors such that their product gives us negative 3 and the sum gives us positive 2. So this is going to be -1 and +3. When multiplied, -3. When added, +2. So we rewrite our equation up there as x squared, and instead of 2x, now we have to introduce -x and +3x, then -3 equals to 0. So we have just replaced 2x with -x and 3x. That is why we were getting these two factors now. So we factorize x to remain with x minus 1, then plus 3x minus 1. X minus 1, that way, equals to 0. From the brackets, we are having x minus 1. Outside the brackets, we are having x and a +3, equivalent to 0. So from this, allow me now, from this point, allow me to say, for us to get a product of 0, it means either x minus 1 equals to 0 or x plus 3 equals to 0. So x minus 1 equals to 0 means that x equals to 1, or x plus 3 being 0, the value of x will be -3 because we have to take the 3 to the other side now when it becomes positive. So these are just the values of x at the turning points. So for us to get the turning point itself, a point should be a coordinate. That is what you're supposed to know. Most of the learners will think that they are now through. Not really. You have to get now the points. So when x is -1, when x is +1, the value of y shall be, now the function that gives us y, the parent equation here, a third x cubed, x is 1, sorry, x is 1 cubed plus x squared, so which is 1 squared, minus 3x, so 3 into 1 plus 2 plus 2. So the value of y when this is computed shall be exactly a third. The value of y shall be a third. And so the equation becomes the coordinates 1 a third. That is it. 1 a third. When x equals to -3, the value of y shall be a third x cubed. So -3 power 3 plus -3 squared, which is our x squared, minus 3 into -3 plus 2. This will give us exactly a +11. Therefore, this other coordinate shall be -3, 11. Yeah, -3, -3, 11. That one. -3, 11. So we have the stationary points, or rather the turning points now. This one and this one. Look at part C. Determine the nature of the turning points of the curve. So the turning points that we've determined up there, we need to know their nature. We need to know their nature. So we have to determine their nature in a simple format, a simple way whereby you shall not train. We need to know some values of x. Then at those values of x, how is the gradient behaving? How is the gradient behaving? So we start with the first. First, we go to the first turning point, whereby the value of x is 1, that turning point. So we shall talk about 1. Then we can have the gradient value now. Y dx. What is the value of gradient? at x equals to 1 and at a point just after 1, which can be a value like 2, and the value of gradient just before 1 at a point like 0. So we go to the gradient function, which is dy dx equals to x squared plus 2x minus 3. So when x is 1, the value of gradient is 0 because this is at the turning point when gradient is 0. What about just after 1, like the gradient at a point like 2? You know, we need 2 squared plus 2 into 2, then minus 3, and we are getting a gradient of 5. Then at a point just before the turning point, because the turning point is 1, we have taken a coordinate like 0. So when x is 0 and we feed it here in this function, we'll get a gradient of -3. Now, how is the gradient behaving towards this turning point and just after the turning point? So we are seeing a gradient of negative, whereby a negative behaves like this. Then after, at the turning point, the gradient becomes 0, so it flattens like that. Then the gradient changes to a positive. So when the gradient changes from negative through 0 to a positive value, then we say that such is called a minimum point. A minimum point. So 0.1 a third is a minimum point. A minimum point like that. Yeah, minimum point like that. Look at another part here, whereby we will talk again, just a similar thing. We get the value of x, then we check the value of gradient at those values of x, then we examine how the gradient is behaving. How the gradient is behaving. Okay. So the second turning point, we want to examine it. It is a point at x equals to -3. So we begin with this point at the middle here, -3, whereby we know at that point gradient is usually 0 because it's a turning point. Gradient is 0. Then what about just after -3 and just before -3? You know, before -3, we can talk about -4. Then after -3, we can go to -2. Let's check at these points. At -2, what will be the value of gradient? So we need -2 squared plus 2 into a -2, then minus 3. Here I'm getting a gradient of -3. Then what is the value of gradient just before -3? We took a point like -4. So we have to go to the function here and check the value of gradient. So -4 is being squared. And when we are squaring -4 in the calculator, remember to open brackets kindly, plus 2 into a -4, then minus 3. This is giving me a positive 5. So you see now, for this particular turning point, gradient is changing from being positive through 0 to a negative. Yeah. And when gradient is behaving in such a manner, turning from positive through 0 to negative, we'll say that such a turning point, which is -311, is a maximum point. Yeah, the maximum point that way. Then with this now, we can proceed to check what part D of this question is talking about. Sketch the curve y equals to a third x cubed plus x squared minus 3x plus 2. For us to sketch this curve, what we need most are the turning points together with their nature. That is done. Then we also have to talk about the y-intercept. So we can get the y-intercept. It's the y-intercept the value of x is usually 0. So substituting x as 0 in this, we need to say that the value of y shall be a third 0 cubed plus 0 squared minus 3 into 0 plus 2. So the value of y just becomes 2. So this curve is cutting the y-axis at 2. So we can now sketch, because we have the turning point together with their nature. We are also having the y-intercept. So we have the y-axis there, then the x-axis here. Then at this point now, we can talk of 1 on the negative side, -2, -3, -4, 1, 2, like that. Then we are having a 1, 2, 3, 4, 5 such coordinates. We can have -1, -2, that's the y-axis. Now we are supposed to sketch. Remember, we are not drawing the curve, we are sketching it. So for us to sketch it, we can come up first with what we're calling the turning points. What are the turning points? -3, 11. So -3, 11 should be a point here. Yeah, up there. Or even, yeah, a coordinate somewhere there. Then we are also talking about another coordinate, which is coordinate 1 and a third. So coordinate 1 and a third, 1 a third, it's just here, just below 1. 1 and a third, sorry. 1 and a third is, yeah, 1 and a third. 1 and a third. Just a minute. The 1 and a third should be on the upper side, sorry. 1 and a third should be there. Therefore, now with this, we can come up with a sketch. Yeah, that way, you know that the curve will cut the x-axis at a point like that. So the first turning point is a maximum. The second one is a minimum. And we also know the y-intercept. So we need to know that it's a maximum point. So the curve is turning in such a manner at that point. Then as it comes down, the curve will pass through +2. But once it arrives at 1 a third, it will turn up that way, because this is a minimum point. So this is the curve, which is equal to a third, x power 3 plus x squared minus 3x plus 2. That is the curve now. Well sketched. Well sketched. So that is how we sketch the curve. We have a number 20 here. A triangle has vertices A, 1, 2, B, 7, 2, and C, 5, 4. Draw the triangle ABC on the Cartesian plane. So we have a Cartesian plane here, whereby we should draw such a triangle. So let me draw the Cartesian plane. And I label me to label the axis first. Choose scales. So that is the y-axis. Then there is the x-axis. Yeah, let me minimize it that way. I will still expand for you to see it clearly. Yeah, that way. That is the x-axis. We have the y at this point. So we can have now labeling 1, 2, 3, 4, 5, 6, 7, 8. Then on the negatives, you can still have the same. -1, -2, -3, -4, -5, -6, -7, -8, -9. That way. Then we can have the positives now. 1, 2, 3, 4, 5, 6, 7. Then the negatives for y, -1, -2, -3, -4, -5, -6, -7. All right. So we have now the Cartesian plane well labeled. Let's plot the coordinates. The first coordinate is A, which is a 1, 2, 7, 2. So 1, 2, 7, 2. So this is our B. This is our A. Then we can also talk about C, which is a 5, 4. So 5, 4, C, that way. Now we can draw the full triangle, the first triangle in this question, which is on transformations. Yeah. That way. That way. So we're having our triangle. So part A is done. Let's check what part B is demanding. A prime, which is a 2, -1, B prime, 2, -7, and C prime, 4, -5 is the image of triangle ABC under transformation T. Draw triangle ABC prime on the same grid and describe T fully. So 2, -1. So 2, -1 is just here. That is where A prime is. Then we're also talking about B prime, which is at 2, -7. So 2, -7, this is where B prime is. We can also talk about C prime, which is 4, -5. So 4, -5 is at a point here. So where C prime is found. We can now join for us to come with triangles. Yeah, ladies and gentlemen, remember to subscribe to this platform, which is the video for online classes. Remember to share with your friends, invite people. Let's grow shifting grades kindly. You see now, the triangle is here. When you compare the first triangle, which I can call it triangle 1, and the triangle 2, which has been mapped here, you will discover something interesting, and that is they are too congruent. They are congruent because their areas are the same. It has only been mapped on another point. So they are congruent. And that means this is not a shear. This is not a stretch. This is not an enlargement. It is not an enlargement. So it can only be a reflection or a rotation or a translation, of which I don't think it's a translation. Yeah, it's not a translation. Therefore, now for us to identify, we now want to distinguish. You know, if it was a translation, it could have been directly such that if we move the first triangle, it can fit in to the other triangle very well without turning it. So we remain with two options, rotation and rotation and reflection. Yeah. So can we identify what kind of a transformation now this one is? So now we join A and A prime. Then we bisect the line which joins that A and A prime. Then we bisect the line that joins them, A and A prime. Then we bisect the line perpendicularly. We bisect the line perpendicularly. So when we do that, we proceed to do the same to C or B, any two. So if we join C and C prime, like that, then we again bisect this line. You discover that the bisector of A prime is different from that of C prime. When we bisect, you discover that the bisector is different. So this is the bisector. So we have bisected C prime. We've bisected A prime. And what we are noticing is that the bisectors are different. That means this is not a reflection. It is now a rotation. So how do we describe this kind of a rotation? How do we describe the rotation? So the point where the two bisectors are meeting, which is the origin, is now the center of the rotation. So to describe this, we have to say that T is a rotation. The center is the origin. So center 0, 0, we give the coordinate of the center of this rotation. Then now, how do we get the angle of rotation? We have to connect one of the points. For instance, I can choose to connect point A to the center, then A prime. A to the center, then to A prime. A to the center, then to A prime. Like that. A to the center, then to A prime. Then we check the angle there. So the angle is a 90 degrees angle. And how is it moving? How is A moving to the center, then to A prime? It is going to the clockwise direction. And being clockwise, then the angle will be treated negative 90 degrees. So it's a rotation. The center of the rotation is 0, 0. And the angle of rotation is 90, which is given a negative 90 because we are moving in the clockwise direction that way. Very important. So that is how a rotation is identified and described. Now to part C of the same. Draw triangle A double prime, B double prime, and C double prime, the image of triangle ABC under reflection in the line y equals to x. Then state the coordinates of the vertices. Y equals to x. All right. So we have to come up with the what we are calling the mirror line first. Line y equals to x. So that line is a line such that if x is 3, y is also 3, a coordinate there. If y is x, x is also x. If x is 4, y is also 4, like that. So along this Cartesian plane, we can come up with the mirror line that way. So the mirror line will pass through there, and we can draw it. Let me use a different ink for the mirror line. Let me choose red. So this is the mirror line, y equals to x. Yeah, it's the mirror line, y equals to x. Now, how do we reflect? We join a point to the mirror line, then we move. We join a point to the mirror line perpendicularly, and we move an equal distance to the other point. So we join A and we move to the other side. So if we join A, then we move to the other side. We join it this way. We join A, then we move to the other side, an equal distance. So we'll be at a point here. That is where A the second image shall be. We do the same to C and B. So we'll join B, then we move to the other side and equal distance. So let me, yeah, this is it. So if we are to do this to B also, if we are to do this to B, you discover that B is at a point here. We join B to the line perpendicularly, then we move an equal distance to the other side that way. So we are here, this is here B double prime shall be. Then we do that to C. Yeah, we do that to C. When we join C to the other side, this is where we shall be. So we join C and we will move to the other side and find ourselves at a point here, C double prime, that way, C double prime, that way. So for A, let's say we move A to the other side through a perpendicular line. So A shall be here. Should also take note of the grid, which is not squared very well. So let me join now to come up with the triangle, the third triangle now, which is the second image. Yeah, that way. That is a B, then to C, and back A, so that we get the triangle. That's it. So we have our third triangle here. Third triangle, we say the second one is here, the first one is here. And state the coordinates. So A double prime is going to be -1, 2. B double prime is a -7, 2. Then C double prime is a -5, 4. Yeah, that way. So we have them that way. The last part, which is a part D, the question says triangle A triple prime, B triple prime, and C triple prime is the image of A double prime, B double prime, C double prime under an enlargement. Center -5, 0. And the linear scale factor of this enlargement is -1. So draw this triangle and state its coordinates. What you're supposed to know is that to enlarge using a negative scale factor, you just need to join a coordinate to the center and you move the number of units to the other side. So if we join, for example, B to the center, you know the center of enlargement is -5, 0. So this is our center, -5, 0. So we move, for example, B to the center and we move equal units to the other side. So we will find ourselves here because it is -1. If it was a -2, we would have moved twice to the opposite side. A -3, we move thrice. So we do the same for A. So we bring A to the center and we move an equal distance to the other side. Yeah, to the other side. So we have to do that for B. So for A, we have to join A to the center. The center is here. Then we move an equal distance to this other side, whereby now A triple prime comes there. Then we have to talk about C now. We join C to this center, which is just perpendicularly up there. Then we move an equal distance, which is to the lower side. So we shall have C triple prime there. Then now we are supposed to join so that we may come up with the triangle. So the last triangle now. A to B, then A to C, and B to C. We get all the boundaries of this triangle. That way. So this is the last triangle, which is the fourth triangle. That way. So that's how we enlarge. It's good for you to note, enlarging using -1 as the scale factor is the same as rotating through +180, which is also the same as rotating through -180 degrees. So that is it. We can state the coordinates. I can see A is at -9, -2, -9, -2. B is at -3, -2. Then we are having C, triple prime, which is at -5, -5, yeah, -4. That way. So that is it. We will be continuing with this paper from number 21 all the way to number 24. So be ready, be standby. We will revise the whole paper. That is just tomorrow. After this paper is when the next part is coming next. Thank you so much for following. Remember to subscribe. Remember to share with friends. Remember our programs once again that you guys can join us for interactive sections through Google Meet, whereby you have to register through my line. Just make a call so that you may know about the programs. They are going to really help you. Through these programs, you can ask teachers questions. You can interact more with the teacher Augustine for chemistry and biology. Then they host shifting grades for mathematics and physics. Remember also that from our platform, you can still get airtime for all lines, Safaricom, Airtel, Telecom, by just going to your M-Pesa, the Lipa na M-Pesa option. Then the pay bill number that you will use is 737356. Then the account number is the number that you're purchasing airtime for. That number, you enter it as the account. It can even be a number of a friend that you're purchasing airtime for. Then once you enter the amount, you shall complete the transaction and the airtime shall be reflected instantly. So thank you so much for the support. See you next time.